Good morning, guys. My name is Akbar. Welcome back to my channel. So today we are going to discuss about RAG. What is RAG? Why we use RAG? Some basic introduction about understanding RAG. Okay. So this is a document. So introduction to RAG. Okay. Now let's understand first of all the definition of RAG. Okay. It stands for what actually? It stands for Retrieval Augmented Generation. It is a process of optimizing. Optimizing means doing a modification, enhancement, all those things. Optimizing the output of a large language model. So this is what it is important. Optimizing the output of LLM. So basically RAG purpose is just to make sure whatever the output that is gonna come from LLM, it should not be a generic. It should be a specific to organization, specific to a project. So if you want anything specific to organization, specific to project, specific to your data in your country, in that case, RAG will come into the picture because LLM is trained on huge amount of data. The output of LLM without RAG is of no use. It's a public property. It's a public information. It's a very common across every query. So if you want to use LLM output for a specific to your organization, your privacy, whatever it is, then RAG will come into the picture. Why it is not possible to train LLM specific to organization? Because it includes billions of parameters, which is practically not possible. And it's a time consuming and it's a huge cost. That's why the RAG comes into the picture. So let me come back to my definition here. It is the process of optimizing the output of a large language model, which is LLM, by having it a reference to an authoritative knowledge based output. Authoritative means exact information, approved information, outside of its training data. See, LLMs are trained on huge amount of data over the internet. It has a billions of parameters. Let me repeat the statement again, billions of parameters. And training LLM with respect to stuff for your organization, for your requirement, for your project, for your data, for your privacy, it's practically not possible. That's why the RAG comes into the picture. Even though if it is possible to train your LLM, it takes a huge amount of time, it takes a huge cost. Okay. In simple words, to understand RAG, let's an LLM look up relevant, up to date and private information. For example, your model is trained on, see what is our date today? 11th of August, correct? Now imagine your LLM is trained till last month only and they don't have information of these 11 days. Okay, it has trained till July 31st and it has no information about 1st of August to 11th of August. Whatever the events that has been occurred during this duration, it won't have any information because your LLM is trained on a restrictions based on a timeline. Correct. So in this case, instead of relying only on LLM, you have to go to RAG. So time wise or private information wise. Okay, specific to organization and project. LLM are trained on vast volume of public available data. This is what I was trying to explain you. LLMs are trained on vast volume of publicly available data. See, this is something really important you have to focus on. LLM is trained on publicly available, not a specific to organization, not specific to a project, not specific to your data, to your startup, nothing. It's publicly available data. It's good that LLM can handle a lot of things, but when you try to use a LLM for your specific organization and a project, then things will change and use billions of parameters. This was I was referring to, billions of parameters. So you have to change a lot of stuff. You have to train them. It will cost you time-taking process to generate answer for a task such as questions, answering, translation, text completion. So answering, translation, text completion. RAG extends these already powerful capabilities to a specific domain or an organization internal knowledge base. This is what you need a RAG. It's good that we have LLM. It's good that LLM is trained on a huge amount of data to answer your query. But when it is coming to a specific organization or a specific domain, specific to your project, specific to your data, you're coming to your security, privacy, then RAG comes into the picture with the additional enhancements. All without the need of retrain the model. This is what it is. You have to use a model, but no need to retrain the model. So you are not going to train your model again. You are just adding an additional input of a RAG to the LLM so that you can use LLM specific to your organization and specific to your project. That's how it is. That's a fantastic stuff what we have understood here. Okay, let's understand. Why do we need RAG? Okay, why do we need a RAG? In the above discussion, we have already discussed. There's a limitations. It's publicly information is available with regards to LLM. LLM get trained on a huge amount of data, billions of parameters, correct? So that's a reason we need a RAG. And moreover, let's understand here what's happening. Using an LLM by itself, a query goes in a prompt instructions is added and the model generates an output directly, works well off for general knowledge. This is what it is, general knowledge. But this simple step has two major limitations. Okay, hallucination and no access to organization data. This I have already discussed to you with you. No access to private data and organization. What do you mean by hallucination? Okay, if you ask some information to an LLM, okay, imagine that information is not there with LLM, but still LLM try to give an answer, even though it don't know. How? Why? Let's understand here. Every LLM is trained on a data only up to a certain date. Imagine here, only a certain date. So LLM is trained here till only. It's of knowledge cutoff. For example, if a model has trained on a data available only until 1st of August, it has no idea what has happened after the world. So that's what I explain you, correct? What will happen after the 1st of August? The LLM has no idea. It has no idea. If asked about events after cutoff, the LLM does not simply say, I don't know. Instead of tends to generate own confident sounding answer so that it doesn't look like a fool. Even though LLM doesn't have an information after the 1st of August, but still it tries to answer your query without saying no or without saying I don't have an content after this particular date. That's what the mistake is. The behavior where model confidently produce incorrect or made up information. Your model is generating the incorrect information, which is considered as a hallucination. So LLM, even though if he don't know about information about a particular event after the 1st of August, because it's a trained till 1st of August, and after 1st of August, this LLM is not having any kind of information, but still it tries to answer you. That's where the hallucination comes into the picture. So why the RAG is coming into the picture? To avoid the hallucination and to access the private and organization data. You cannot give an access to the LLM to your organization data, which cost you a lot. There's a high chances of getting data leak information or privacy issues and everything. Now let's understand the overall the RAG. Okay, no access to private, which I've already discussed with you, the RAG solution. Instead of retraining or fine-tuning the model every time data changes, RAG connects to LLM to an external updatable knowledge base, a vector database. The model retrieves the relevant information at a query and uses. So basically, LLM takes input from RAC with regards to organization, with regards to updates. The data what is in vector database. So user query is going to be embedded. Embedded in the sense it's converting text into vector. Okay, and the data will be stored in the chunks. So you need to understand this terminology a little bit. Going forward, you can understand here. The overall the RAG solution is, instead of retaining or fine tuning the model every time data changes, RAG connects to LLM. Just focus this point. RAG connects to LLM to give some inputs, which is a private information, which is relevant to the query, which LLM doesn't have an access, and give a prompt stating that to answer the query, LLM has to use the inputs from RAG in such a way. Okay. Now let's understand the architecture of a RAG, high level flow. So user gives a query goes to VectorDB, and from VectorDB it goes to LLM, and from LLM the output comes into the picture. Imagine if there is a no VectorDB. A query is going to directly to LLM, which means there is a no RAG here. RAG is not involved here. So this VectorDB is having two type of pipelines, which I'm going to explain you in upcoming next sessions. Ingestion pipeline and retrieval pipeline that we'll see. The overall high level flow of RAG is user, query, VectorDB, LLM, and output. So this is what the diagram is. Okay. Now, next key building blocks, parsing. So what is happening here is, so when something user is giving text and going to VectorDB, well, how the information is going to change here. So you need to understand data ingestion pipeline and data retrieval pipeline. Parsing in the sense raw data, the data which is a structured and non-structured data, which is in a PDF readable format, HTML, Excel, SQL database, or any unstructured data which is acting as an input, and breaking it down into smaller pieces called chunks, because VectorDB has to save the data in chunks. Good chunking is one of the most important step building an effective RAG application. If you have to build a specific strong RAG application, what is the most important thing? Good chunking is one of the most important. Okay, so the data is raw data, which is in a readable format, and structured data and unstructured data, breaking down into small pieces called chunks. Okay, is that clear now? Chunks. Good chunking is one of the most important step in building effective RAG application. So if you have to build a RAG application, your data has to be in a proper chunking information. Now, embedding. Embedding in the sense the process of converting text into vectors. So this is what a critical thing here. So when something going to vector database, they cannot be in a text format. It has to convert into as per the destination requirement, correct? So into the vectors. So text has to convert into the vector, that's considered as an embedding. A numerical representation of a text. So whatever the text that you give, it will convert into a numerical representation, so that as per the standards of a vector DB. Vector allows algorithm such as cousin, similarity search to find pieces of text. So these algorithms are really going to help for a similar search. Okay. When your ingestion pipeline and retrieval pipeline you're talking, you have to understand about parsing, which is giving an inputs of a data. Now next is embedding, because your vector DB needs the information in a vectors. It cannot accept a text. You have to convert the text into the vectors, and the data has to be save in the chunks. for a specific RAG applications. So the data converts into the vectors and then store into the VectorDB. So before that, data gonna divide in a chunking and saved in a DB and numerical format. So whatever I mentioned here, numerical representation of text. Now, vector store or VectorDB. What is happening here? A specialized database that stores embedding vectors generated from the organization data. It acts as an external knowledge base to the LLM. Guys, this is really important here. Why? Because external knowledge base that the LLM did not originally have access to. What is your sorry, my bad. Your RAG, what is your RAG is doing? It's having the external knowledge base that LLM didn't have originally. LLM doesn't have an access to private data. That's where your vector come into the picture. Vector store or VectorDB. Context. What is this context and what is this prompt? Let's understand context. The relevant chunks of information retrieved from the VectorDB in response to a user query based on the similar search. The relevant chunks of information retrieved from the VectorDB. Whatever you're giving a query to the VectorDB and whatever the output that you're giving, the vector chunks of information retrieved from the VectorDB in response to a user query based on similar search. So whenever the response is coming up from the VectorDB and you have to pass an instruction, use these inputs in LLM to answer the query of the user. Next, prompt and instructions given to LLM that tells it how to behave. For example, use the following context to answer the query question in a RAG system. So basically, you need to understand this, how the data is going to input, how the data is going to convert, how the data going to store, and then how this context and prompt combination will help you to answer the user query, to retrieve the data from VectorDB and giving instructions to LLM to use this external information to answer the user query. So data ingestion pipeline and see raw data, parsing, embedding, and vector. So data is going to store here. That's what your data ingestion pipelines. You are going to inject the data in the database. Now, once you inject the data in the database, now the retrieval pipeline. So user query embedding, user parsing embedding. Okay, this retrieval pipeline here, user query embedding, user parsing embedding. So VectorDB context, prompt, LLM, and output. So in detail, we'll cover in the next upcoming sessions. So basically, data ingestion pipeline is a data is going to store in the VectorDB. Retrieval, every time a user asks a query, query embedding, similarity search, context. So whenever user asks a query and how best we are going to utilize the RAG and giving instructions to the LLM how to use the information in the RAG and how to answer the query, not based on the data what it has publicly, based on the information inputs coming from RAG. Okay, RAG fine tuning and all those things. So I hope you are very clear here on the basic steps here. So what you need to understand is basically LLM is something which is trained on a huge amount of data. You cannot use a LLM directly to for organization purpose, for your specific project requirement, for your privacy purpose. You need a RAG additional information. RAG is something which is having an specific to organization, specific to project. Why can't we train LLM? Yes, you can train LLM, but that's gonna take a time, cost, everything. So better to use a RAG. RAG is specific to organization, project, requirement, all those things. RAG is having the database in terms of a VectorDB. Okay, as I mentioned, the VectorDB, you need to understand how the data is gonna structure data, unstructured data, how the data inputs happening, readable format, parsing, and then embedding, converting the text into the vector, how the data is going to store in the DB, and then context and prompt retrieval pipeline as part of retrieval. Till here, it's a data ingestion, and this section is a data retrieval pipeline. This is a combination for a perfect output. So I hope this video has helped you to understand the basic level of introduction to RAG. So please click on like and subscribe my channel. I really appreciate your support. Thank you very much. Thanks for your time. Thank you. Please click on like and subscribe my channel. Thank you guys. Thanks for your time. Bye-bye.